Okay, how would we work out I to the power of I? Okay, well, we know it's imaginary as I is an imaginary number. So first we want to write this in the form Z to the W, where Z equals I and W equals I, which you can just see. Okay, now we want this to be something that we can actually approach. You can't just straight up look at I to the I and pick a value. So let's try and get this into a form we can actually understand. So one thing about complex numbers is we know this form is a very handy thing to have. Z equals R e to the I via this exponential form. So what if we can have I to the I or Z to the W equals E of W ln Z for the reason that we write this, E to the ln Z is the same as Z. Right, this is just equals that because E and ln cancel out. And now Z to the W is equal to W times ln Z because, like we just said, E to the ln Z equals Z. So that means I to the I in that form is E to the I ln I. And this is a lot more easier to attack because we can actually work out ln of I in the form, you know, this is the same thing as ln Z, which would equal R plus, no, ln of R plus I theta, because, let me quickly write this actually. Sorry, Z equals R to the exponential form. If we take the natural logarithm on both sides, ln Z equals ln of R plus I theta. And so, that means that ln of I would equal ln of R plus I theta, where R is the modulus of I equals 1. And then if we want to work out theta, let's do it on a diagram. This is the imaginary axis. This is real axis. I is about here. And clearly that's pi by 2 for the angle, plus 2 pi k for values that go around in a circle. So ln of I equals, ln of 1 is 0. Let's write that down. Ln of 1 equals 0. You can work that on a calculator and you'll know that. Plus I theta, which we just worked out as pi by 2 plus 2 pi k. Sorry if my pi's look like muse. So now going back to this, I to the I equals e to the I of ln I, which we just worked out. Pi plus, oh, we should have, I times pi plus 2, pi over 2, I mean, over 2 pi k. Now, this equals e to the I squared of pi by 2 plus 2 pi k. We know I squared equals minus 1, so I to the I equals e of minus pi over 2 plus 2 pi k, which is our final answer of I to the I. And the nice part about this is a totally real answer. You can work this out. This is, by the way, for any k, such that k is a positive. Well, it doesn't have to be positive. Sorry, such as k is a real integer. And yeah, the nice part about this is it's a fully real answer. You can type this in a calculator. So yeah, that's the answer to I to the I.